Our solar system is a vast, dynamic, and often terrifying neighborhood in the cosmos, a swirling disk of planets, moons, asteroids, comets, and a blazing star at its center that could wipe out life as we know it in an instant. Let's start at the beginning, about 4.6 billion years ago, when a massive cloud of gas and dust, known as the solar nebula, began to collapse under its own gravity. This wasn't some gentle process. It was chaotic, violent, with immense pressures and temperatures building up as the materials spun faster and faster, flattening into a protoplanetary disk. At the heart of this maelstrom, the sun ignited, fusing hydrogen into helium in a nuclear furnace that releases energy equivalent to billions of atomic bombs every second. That newborn sun blasted out a solar wind, a stream of charged particles that cleared away the lighter gases, leaving behind rocky remnants that would coalesce into the planets we know today. But imagine being there. Temperatures soaring to thousands of degrees, debris smashing together at incredible speeds, forming molten worlds in a cosmic blender. It's a miracle anything stable emerged from that hellish birth. The sun itself is the undisputed ruler of our solar system, a G-type main sequence star that's about 109 times wider than Earth and contains over 99.8% of the system's total mass. It's a seething ball of plasma, with a core temperature of 15 million degrees Celsius, where fusion reactions rage nonstop. The surface, or photosphere, is a turbulent sea of granules, each the size of a continent, bubbling up from convection currents below. But don't let its steady glow fool you. The sun is a monster. It unleashes solar flares, eruptions of magnetic energy that can release as much power as 1 billion hydrogen bombs, hurling radiation and particles toward the planets at nearly the speed of light. These coronal mass ejections can strip away atmospheres, fry electronics, and even endanger astronauts. In 1859, the Carrington event, a massive solar storm, lit up the skies with auroras visible as far south as the Caribbean and caused telegraph systems worldwide to spark and catch fire. If something like that happened today, it could knock out power grids, satellites, and communications, plunging modern society into chaos. And that's just a taste. The sun is slowly getting brighter, about 10% every billion years, and in another 5 billion years, it'll expand into a red giant, swallowing Mercury, Venus, and possibly Earth in its bloated, fiery envelope. Our star, the giver of life, will one day become its destroyer. Orbiting closest to this stellar beast is Mercury, the smallest planet, a scorched, cratered world that's more like a giant cannonball than a habitable sphere. With no substantial atmosphere to speak of, temperatures swing wildly from 430 degrees Celsius on the day side to 180 degrees at night, a brutal cycle that would cook and then freeze any unprotected human in minutes. Mercury's surface is pockmarked with impact craters from billions of years of bombardment, including the massive Caloris Basin, over 500 kilometers wide, formed by an asteroid smash so powerful it sent shockwaves around the planet, creating weird, hilly terrain on the opposite side. The planet's core is enormous, making up about 85% of its radius, likely the remnant of a catastrophic collision that stripped away its outer layers early in its history. Imagine standing on Mercury, no air to breathe, radiation bombarding you from the sun, and the ground beneath your feet a mix of metallic iron and silicate rock that's been baked solid. Spacecraft like NASA's MESSIC NGR probe revealed water ice in permanently shadowed craters at the poles, hidden from the sun's glare, but accessing it would be a nightmare in that vacuum. Mercury spins slowly, with a day longer than its year, 88 Earth days to orbit the sun, but 59 days to rotate once, creating a bizarre resonance where the sun appears to rise, set, and rise again in the same spot. It's a world of extremes, a testament to how hostile the inner solar system can be. Next out is Venus, often called Earth's twin because of its similar size and composition. But don't be deceived. This is a hellish sibling, a runaway greenhouse effect turned nightmare. shrouded in thick clouds of sulfuric acid that reflect sunlight and make it the brightest planet in our sky. Venus has an atmosphere 96% carbon dioxide, with pressures 92 times that of Earth, enough to crush a submarine like a tin can. Surface temperatures average 464 degrees Celsius, hot enough to melt lead, and the air is laced with toxic gases and acid rain that would dissolve your skin. Volcanic activity dominates, with over 1,600 major volcanoes, some possibly still active, spewing lava across vast plains. The planet's rotation is retrograde, spinning opposite to its orbit, so the sun rises in the west and sets in the east. And a day on Venus lasts 243 Earth days, longer than its 225-day year. Probes like the Soviet Venera landers survived only minutes on the surface before succumbing to the heat and pressure, sending back eerie images of a rocky, barren landscape lit by an orange sky. Venus might once have had oceans, but the greenhouse trap boiled them away, leaving a desiccated corpse of a world. If Earth ever tips into uncontrollable warming, Venus shows us our potential fate, a cautionary tale orbiting just 41 million kilometers away at closest approach. Then there's Earth, our blue marble, the Goldilocks planet where everything is just right for life as we know it. But even here, the solar system's influences make it precarious. We're in the habitable zone, where liquid water can exist, with a magnetic field shielding us from solar radiation and an atmosphere that's 78% nitrogen, 21% oxygen. Perfect for breathing. Yet, asteroids and comets from the outer reaches periodically slam into us, like the Chicxulub impactor 66 million years ago that wiped out the dinosaurs in a global firestorm and dust cloud. Our moon, formed from a Mars-sized protoplanet collision that ejected debris into orbit, stabilizes Earth's tilt, preventing wild climate swings, but it's slowly drifting away at 3.8 centimeters per year, which could eventually destabilize our axis. Earth's core generates the magnetic field, but it flips polarity every few 100,000 years, and during transitions, radiation exposure spikes. We're also at the mercy of the sun's cycles. Solar minima could trigger mini ice ages, while maxima bring more storms. And beyond that, supervolcanoes, earthquakes, and tsunamis remind us that our planet is geologically alive, shaped by plate tectonics that recycle the crust, but also cause devastation. Life thrives in diverse biomes from deep sea vents to polar ice, but the solar system's vastness isolates us. We're a fragile oasis, dependent on a thin layer of air and water. Beyond Earth lies Mars, the red planet, a dusty desert world that's captivated humanity for centuries with its potential for past life and future colonization. Half Earth's size, with gravity about 38% of ours. Mars has the largest volcano in the solar system, Olympus Mons, 3 times Everest's height, and the deepest canyon, Valles Marineris, which stretches longer than the United States is wide. Ancient river valleys, deltas, and lake beds suggest Mars once had flowing water, perhaps oceans, billions of years ago, before its thin atmosphere. Mostly carbon dioxide at less than 1% Earth's pressure. Let the water boil away or freeze underground. Today, polar ice caps of water and dry ice sublime in seasonal cycles, and dust storms can engulf the entire planet, blocking sunlight for months. Rovers like Perseverance have found organic molecules and signs of ancient habitability in Jezero crater. But radiation bathes the surface without a strong magnetic field, and temperatures plummet to 140 degrees Celsius at night. Human missions would face perchlorate, contaminated soil that's toxic, and thin air that requires pressurized suits. Mars has 2 tiny moons, Phobos and Deimos, captured asteroids that are doomed. Phobos is spiraling inward, and will either crash into Mars or break apart into a ring in about 50 million years. It's a world of faded glory, a reminder that planets can lose their livability, and exploring it means braving isolation with communication delays up to 20 minutes each way. The asteroid belt between Mars and Jupiter is a rubble pile of leftovers from the solar system's formation. millions of rocky bodies ranging from dust to the dwarf planet Ceres, which alone holds a third of the belt's mass. Ceres has a subsurface ocean of briny water, cryovolcanoes that erupt ice, and bright salt deposits, hinting at geological activity. But the belt is a hazard zone. Collisions grind rocks into meteoroids that can pelt inner planets, like the one that exploded over Chelyabinsk in 2013, injuring over 1,000 with its shockwave. Larger asteroids like Vesta, with its massive South Pole crater, show evidence of ancient magma oceans, but mining them for resources like platinum could be risky amid the chaotic orbits. Jupiter's gravity stirs the pot, flinging objects out via resonances, creating gaps like the Kirkwood gaps. It's not a dense field like in movies. You could fly through without hitting anything. But the potential for Earth crossers makes it a cosmic shooting gallery, with NASA tracking near-Earth objects to avert doomsday impacts. Jupiter, the gas giant king, is a behemoth 11 times Earth's diameter, with mass 318 times greater, dominating the outer solar system. Its atmosphere is a striped swirl of ammonia clouds, with the Great Red Spot, a storm twice Earth size that's raged for centuries. Winds howl at 400 mph, and lightning bolts 1,000 times stronger than Earth's crackle through the haze. Below, pressures turn hydrogen into metallic liquid, generating a magnetic field 20,000 times Earth's that traps radiation in belts deadly to spacecraft. Jupiter has over 90 moons, including Io, the most volcanically active body, spewing sulfur plumes 300 kilometers high Europa, with its icy crust over a subsurface ocean that might harbor life, cracked by tidal forces. Ganymede, larger than Mercury with its own magnetic field, and Callisto, a cratered ice ball. Jupiter's gravity shepherds the asteroids, captured comets like Shoemaker, Levy 9 that slammed into it in 1994, scarring the atmosphere with Earth-sized bruises. It's a protector, slinging threats away from inner worlds, but also a slingshot that could send them our way. Exploring Jupiter means navigating radiation that can fry electronics, as the Juno probe does, revealing a fuzzy core and deep water abundance. Saturn, the ringed wonder, is a lighter gas giant, 9.5 times Earth's diameter, famous for its spectacular rings. Billions of ice particles from micron-sized dust to house-sized chunks, spanning 282,000 kilometers but only 10 meters thick in places. Formed perhaps from a shattered moon or comet debris, the rings rain material onto Saturn, and they're disappearing over millions of years. The planet's atmosphere has hexagonal storms at the North Pole, a vortex 50 times larger than Earth's hurricanes, and winds up to 100 ml. Titan, Saturn's largest moon, is a hazy world with methane lakes, rivers, and rain, an organic, rich analog to early Earth where tholins, prebiotic chemicals, fall like snow. Enceladus geysers spew water plumes from a subsurface ocean, containing salts and organics that hint at hydrothermal vents, potential cradles for life. Other moons like Rhea have tenuous oxygen atmospheres, and Iapetus has a two-toned surface, one side dark as asphalt, the other bright as snow. Saturn's low density means it could float in water if you had a big enough tub, but its core pressures create diamond rain from compressed carbon. Cassini probed Dove through the rings, revealing their complexity, but Saturn's beauty hides dangers. Ring particles could shred spacecraft, and radiation belts pose risks. Uranus, the sideways ice giant, rolls on its side with a 98-degree axial tilt, likely from a massive impact, causing extreme seasons where poles get 42 years of sunlight or darkness. Its bland blue atmosphere hides fierce winds up to 560 month and temperatures down to 224 degrees Celsius, the coldest in the solar system. Composed mostly of water, ammonia, and methane ices, Uranus has a rocky core and a magnetic field offset by 60 degrees, wobbling chaotically. Its 27 moons include Miranda, a Frankenstein world of jumbled terrains from past disruptions, and rings that are dark and sparse. Voyager 2's flyby in 1986 showed a featureless orb, but recent observations reveal infrared auroras and possible ocean moons. Uranus leaks atmosphere into space via plasmoids, and its remoteness, 19 times farther from the Sun than Earth, makes study hard with sunlight 3400th as intense. Neptune, the distant blue giant, is a windy world with gales up to 1/500 mph, the fastest in the solar system, and the Great Dark Spot, a vanished storm the size of Earth. Temperatures average 214 degrees Celsius, but internal heat drives weather despite faint sunlight. Triton, its largest moon, orbits retrograde, likely captured from the Kuiper Belt, with geysers erupting, nitrogen 8 kilometers high, and a thin atmosphere. Neptune's rings are clumpy, and it has 14 known moons, some in chaotic orbits. Voyager 2 revealed supersonic winds and diamond rain possibilities, but its distance, 30 AU, means one-way signals take 4 hours. Beyond Neptune lies the Kuiper Belt, a icy debris disk with dwarf planets like Pluto, a heart-shaped world with nitrogen glaciers, mountains of water ice, and a hazy atmosphere that freezes and thaws with its 248-year orbit. Pluto's moon Charon forms a binary system, and others like Styx dance in resonance. Eris, Haumea with its ring, and Makemake add diversity. Comets originate here, icy messengers that, when perturbed, plunge inward, sometimes impacting planets. The Oort cloud, a hypothetical spherical shell a light year out, holds trillions of comets, occasionally sending long-period visitors like Hale-Bopp. The heliopause marks the solar system's edge, where solar wind meets interstellar space, as Voyager 1 crossed in 2012. Our solar system is a fragile balance of gravity and motion, with exploration revealing wonders and perils. From Mercury's hell to Neptune's storms, it's a place of beauty and terror, urging us to protect our home while reaching out. And if you're inspired to learn more, platforms like Brilliant can deepen your understanding of planetary science through interactive lessons on orbits, gravity, and more. Check them out for mind-expanding puzzles. Thanks for joining this journey through our cosmic backyard. Stay curious, and remember, in the grand scheme, we're all stardust navigating this vast system.